Coming up on the FRC Open Alliance show, it's 694 StuyPulse from New York coming in, and what an incredible set of things we're going to be taking a look at here. I mean, there are so many different features and capabilities that this team is looking at accomplishing, and I really love how quick their spindexer is able to get fuel out as well, too. One of the other things I really want you to focus on here is this miniature turret that they're using that they put on the Kitbot to essentially run a turret without having a full turret. I think that's a really cool thing that teams can really look at implementing either this year or in future years as well, too. So great overviews we'll be hopping into. Let's learn more here on the FRC Open Alliance show. This video on fun is brought to you by our viewers, supporters, members, and also in partnership with the following. AndyMark provides superior service and reliability that teams expect at andymark.com. From the Robotics Launcher Expansion Kit to the SDS MK4 and 5 Swerve modules, your team can be ready for rebuild. Don't forget to stock up on game-specific elements, bumper kits, and new for 2026 products at andymark.com. For over 100 years, Kettering University has offered a better education because from day one, that education has been built on hands-on, co-op learning. Kettering's impressive alumni network includes founders, presidents, CEOs, and frontrunners who have a reputation for transforming industries with their resolute leadership. Apply today at kettering.edu/first. Let's welcome on the Open Alliance show at 694 StuyPulse Robotics coming in out of New York. Well, welcome everybody. I love following your build blogs and your team every single year. So why don't you introduce yourselves? Let us know what you're doing in the team, and we got a lot to dive into. Let's hop into it.
Hello, I'm Rachel, and I'm Ellen, and we're the co-director of Design and Electronics.
Hi, I'm Philip. I'm a mechanical lead on the team, as well as the driver.
And my name is Kalimul. I'm the president of software on 694 StuyPulse.
All right, so let's just hop into it, and let's immediately talk about our drivetrain. So a big part about what we are doing, or a lot of our testing was related to our drivetrain. So one of the largest things this year, especially with the addition of the bump, is that whether or not we wanted to raise or lower our modules. And so the benefit to raising our modules is initially we thought that we could easily go over the bump in a very smooth fashion. But actually after testing that, which I will show later on our Kitbot, we made a Kitbot with raised modules. We realized, oh no, it wasn't actually much better. And so the issue, again, we tested it and we decided that after multiple tests, as well as watching videos from other teams, that we wanted to lower our drivetrain. And this is because we gained an extra 2 inches of space, which we think was just so vital and important that we couldn't, that the benefit of raising it just couldn't match up for that. And for context, our team, we want to go over the bump and underneath the trench. So we're already going to be lower than other teams, and so we really needed that space. To compensate for this, we're adding things like Delrin, which is just like this very slick material onto the bottom of our bumpers, as well as on the bottom of our belly plate. And this is just so we can kind of glide over the top of the bump and get over smoothly. And we've tested this, and we're actually even putting it onto our Kitbot right now, and it's worked pretty well so far. And actually for there are different things that we can, there are two different wheels models that we are deciding from. The first one being molded tread, and the second one being the black nitrile, which we used from last season. The molded tread is good because it just has a better grip. It digs into the carpet and is better. But the problem is it has the grip is way worse on the top of the bump. So to compensate for this, or to test this, what we decided to do was we put some old black nitrile treads on our old robot. We tested going over the bump, and we saw that it was actually worse or about the same when using the molded tread. And so because of that, we decided to go to molded tread. Now, on to other parts, our robot dimensions. We decided to make our robot a rectangle, 31.5 by 23 inches, because this size maximizes the volume of our hopper when it extends. Other things that we are doing for our electronics, we are actually doing under the belly electronics. For the ease of our robot and design, we are going to have a brain pan on our robot. And because of that, we don't really have space to put our electronics anywhere else. So we're actually going to do under the belly electronics, which we actually did on this robot. It's kind of hard to see, but if I pick it up, you can see all the underbelly electronics. This is from an off-season project that we did this past summer. So we're very comfortable in doing it now. And then onto the bumpers. So this is a bit of a sample of how we're layering our bumpers. It's pretty similar to what we were doing last year. We have a hard Baltic birch here for the backing, and then we have a softer foam, and then we have a harder floor tile, kind of like we're trying to model it kind of like a helmet. We're experimenting with putting HDPE on the back, but we didn't have time to test it really in the off season, and so we went with the thing that we've used before. We're also curving our edges because we want to have a lower profile and we want to be able to get around defense easier. So a smaller, not like edged bumper like we had last year, as we discovered in matches, it's just not great for getting around robots. We're also doing split bumpers. So we're doing 2-piece bumpers for the robot. And this is because we can't actually put the bumpers on over the top if the entirety of our robot is if the entire footprint of our robot is filled up by the hopper. And so we're splitting the bumpers into 2 parts. And another reason for this is that we are actually going to have a gap in between the bumper to basically funnel the uprights into the climber, which will help with alignment when driving. And so now I'm going to pass it on to Rachel for other parts of our robot.
So to give more context, our robot archetype is very similar to the current AlphaBot. We'll have a 6-bar intake as well as a spindexer and a handoff that goes right into a turret into a hooded shooter. So that is our archetype, and our AlphaBot is very similar to it. And we also have a separate climber to climb with L1. And into the more details of each mechanism. So for the first mechanism, which is the intake, we experimented with different types of rollers, including different diameters and diameters of compliant wheels, as well as polycarb rollers. So what we realized is that we really want to go with a 3-inch diameter. So on this intake, some parts of them are 35 a diameter and 40 a diameter. So for our AlphaBot, we kept it a static fixed intake, but we also realized that we really want to go with the 3-inch compliant wheel, as it has a larger surface speed when ran with the same ratio compared to a 2.25-inch compliant wheel. And additionally, in order to have a smoother transition in from the intake to the spindexer, on an actual 6-bar intake, we'll be having a 2-inch polycarb rollers, 2 of them, which will be after the very first roller. Additionally, we have the kicker shaft here that's to prevent the dead zones, that will also provide a smooth transition onto our bumper and directly into our spindexer. And to move on to how we came up with our 6-bar geometry, we'll provide it through CAD. So here is the CAD of our master sketch for our intake. So there are many people who are confused of how to develop the geometry of the 6-bar. So we first start off with the fully deployed position. So they are the 3 different rollers for a deploy position with the smooth transition of the ball path. And then from then we develop the different positions. So when it's fully retracted, as well as when it's fully out. And you see it's directly related to the deploy position. And if you see here, the important part is that there's basically almost close to none dimensioning, except for a few. And they're all based on constraints based on this geometry that we need. And we also want with a 6-bar intake in order to be able to fully hit walls and other robots without getting that much damage, and that could just simply retract. So now going into our indexer types, we weren't sure which indexer was the best fit for our robots, so we tested many types. For example, we also went with the conventional spindexer as well as oval shape of the spindexer. This is the spindexer with the cake layers, but we also had many inspiration from 2017 robots, for example, such as the Neutron spindexer, but we also had other versions such as the 118 with the belts, as well as another iteration with the star wheels on them. However, a lot of them had many great potentials, but we went with the one we were most comfortable with. And the reason why we went with this cake spindexer, which has a stack of stealth wheels, is because it provides a slight agitation from the bottom and provides a very consistent throughput into the shooter and the handoff. And moving on to the handoff, we'll have different compliant wheels with sushi rollers running at the same surface speed as the compliant rollers in order to provide a smooth transition into the shooter. One thing that we want to emphasize is we don't want any bottlenecks in any part of our robots, so we want everything smooth from every part that fully leads to the outtake.
Can we jump a little bit into your spindexer wheels that you have on there? So you have multiple different types of cascading wheels essentially in the middle of that spindexer. Can you just talk a little about some of the testing done? When we talk to other Open Alliance teams, some are looking at maybe having things rotate 2 different ways. Some have just gone with a straight cylinder. Talk to me more about what you have there.
Yes, we tried different types of output for the spindexer as well as the stack. So we also tried on the output having vertical wheels or having different larger diameter in order to create a barrier, as well as simple polycarbonate plates. But realized that some of the parts, such as vertical rollers or stealth wheels, actually cause jams, which is why we went with a simple polycarb transition with a row of compliant wheels. And for our main roller here, we did multiple types of designs. We even 3D printed a cone shape, different curve shapes, tried different stacks, tried star wheels. But currently, we realized this small agitation from the bottom, as well as this part with stealth wheels that actually creates kind of like a blender. So if this part is like a smooth surface, it actually does not able to like remove the jams as fast as possible. And currently, we're also trying to remove jams above near the hopper. So we use like star wheels that provide very effective of actually decreasing the jams. And on the alphabot, and actually we're still working on a prototype. We're still trying different type of layers and different types of design for the main spinning wheel. But this is not the only spindexer. Oh, sorry, yeah.
I was going to say there was a video that we showed on screen, and we actually featured that in another content piece that showed you guys like indexing really, really fast. Have you actually measured how quick or how many balls per second you're actually getting out based on that?
So we counted based on our videos, and we have around 8 balls per second. And just to go more into the other spindexers we tried many like different flaps, like polycarbonate flaps, aluminum flaps, but we realized having a uniform circle just made consistent throughput and uniformity. Because when you tend to have like slots for the flaps, it creates like gaps that are sometimes the flaps are not filled, which provides more inconsistencies. And any wall or like active roller we had that extended as a wheel causes jams because the cake rotates as well as the exit rotates. So whenever they contact together, they can cause jams. So this is why we went with this kind of design. But we're continuing to test it. So going more into detail, after going through the handoff, we have a turret. So initially, because this is our first time implementing a turret into an in-season robot, we actually created a mini version of the turret, which actually you can see here. We created a mini version of a turret so that software can have early testing as well as an aim, which you can see a video we provided that is good for auto alignment. So we provide this for software for early testing, and we also use the max swerve deep groove ball bearings to imitate the clamping we'll do for the bearing on the mini turret, which is what we implemented here. There's an X contact 8-inch X contact bearing inside from West Coast Products, and they have the same clamping type as the mini turret, and it provides nice stability. And this is almost exact same a method we'll be implementing on our actual robot with 3D printed herringbone gears down here. And continuing on, we have a hooded shooter on top of our turret. And we had many prototyping versions. So for example, this is actually V3, but for V1, we tested compression, and we also tested various backing materials. So such as we found that the yoga mats provided nice consistent shots due to the added friction. And then for V2, we had added more compression because we found that the ball shot out further with that. But we also tested different angles with version 2. So we knew the minimum and maximum angle we need to shoot up from the hub, but as well as from the trench. So we were able to do many angle testings with that. But now the version 3 was our closest version to what we have on the robot, where we use Krakens. We actually had 2 Krakens. One's missing right now because we're done prototyping, but we actually had 2 Krakens here. It was the ratio was 1-to-1, which we thought worked well. So we decided to keep that for our actual robot and the AlphaBot. But another cool thing that we tested was that we actually had many different flywheel gear ratio configurations. So we had, right now it's currently 1-to-1 because that's the last thing we tested. But we also had an option as the gears on the side here provided us many options so we could test the different gear, how much we can gear the fly up by. We did 4-to-1, 1-to-4. And we tested both 1-to-4 and then as well as 1-to-1. But based on when we were looking at our design, based on how the packaging works and how much space we have available, we calculated different flywheel dimensions 1.5 and how much we can speed up by like 2 inches. And we also calculated 4-to-4-inch one here. But we realized based on our space and packaging limitations, we realized the 1-to-1 4-inch flywheel would be best considering all the rotational kinetic energy as well as the inertia and the rotational momentum. And so another interesting that we use worn out 40A durometer stealth wheels because we realized that they provide the best grip onto the fuels.
How did
And
you
this
come
is
up
our
with using worn out wheels was the best? That's awesome.
So we were going around. It usually began in the beginning of the season. We pick up a bunch of materials and then we start rubbing them on. But the intake worked well with the same material, though it's compliant. And we realized the more worn out it gets, the better it grips onto a ball. So we applying the same mindset. We also did the same thing for the shooter, and it works pretty well. And I think we'll continue using it.
It's also great that we have a lot of these wheels left over from our 2024 season. So we're definitely going to put them to use.
So for the AlphaBot, which a lot of the variables will implement in actual robot, currently this flywheel is geared up, I believe, like 1 to 2.3, though we'll probably go with 1 to 1 on the actual robot. But the same thing we'll keep is the ratio between the Kraken and the main wheel, which is just 1 to 1. Due to the momentum of the ball shooting out from the shooter, we realized we need to have a stable hood. So we did a reduction of about 216 to 1. So the hood does not budge, though it can change with the ball, but this does not budge. And a reduction allows us to have a very stable hood. And yeah, and as for our wire management for our shooter and turret, we said I provide the images of the master sketch, but we decided to use a wire tuning vacuum hose because it has multi-directional flexibility, unlike an e-chain, or it also provides extra protection unlike regular sheets. So we've planned to use this vacuum hose. However, to package it, we want to package it in our turret structure where we use a constant force spring and wrap this vacuum hose around as shown in the image, and we model it based on a sketch between the minimum and maximum lengths we need. So it's very similar to like a filament spool or even a tape measuring tape. So that is the idea we'll go with, and yeah, they provide nice protection. And going on with the hopper. Oh, so for hopper, we'll be doing a vertical as well as a horizontal extension. For the horizontal extension, we'll be using the intake to deploy to maximize our space. But for the vertical extension, we'll be using pin slots for passive extension. Or we might also be able to incorporate with the climber, but we'll be figuring that out. But as of now, we have about 75 ball capacity in our AlphaBot hopper when it's not extended, and this is not extended version. So we'll be attaching it to our AlphaBot soon, but this is the non-extended version of our actual robot, and it has about 75 ball capacity. And we're still currently debating whether we should have like maybe a partial, vertically expanding, or maybe even angle to not block our trajectory of the balls. Yeah, we might even chamfer the hopper. And the last mechanism, which we'll be having on the actual robot but not on the AlphaBot, is the level 1 climb. And the first thing when we saw the game during kickoff was it reminded of our 2024 climber on our robot, which is basically 2 hooks that linearly extend. And with that simple idea, we decided this will be a very easy way to do L1. And we thought of multiple designs of just having one-sided of like the Izzy version, or having a basically one-stage elevator, which the one stage is a carriage, as well as a multi-stage telescoping arm. However, with the final design, we went with a one-stage elevator. This is because we are able to maximize the custom bearing height in order to provide additional stability, as well as a better integrated structure into the drivetrain through crossbars for durability. And this also allows us to upgrade in the features to maybe something with an L3 climb. All of our CADs and links in YouTube's and Instagram, as well as our Chief Delphi post, is linked, so please look at them.
Yep. Okay, so now I'm going to go on to our Kitbot. And so here's our Kitbot. Let me just have the bumper on here at the start. But basically, the purpose for our Kitbot this year was we started doing this last year, where we we basically put the Kitbot on one of our old swerve drivetrains. And so we decided to do the same thing again this year, because it's really good for driver practice, as well as kind of figuring out like cycle times, as well as helping software test things. So this year, as you can see, as I'm sure many teams know as well, the Kitbot is basically 2 parts. It comes with the tank drivetrain and then this entire piece right here, which is just the hopper, the shooter, the intake, all of that. The issue is the Kitbot is basically has a cutout, and the cutout extends to the ground, and it's pretty hard to integrate into an already built into an already built drivetrain. And so what we decided to do is, since we also wanted to test the raised drivetrain, we took 4 modules off of an old robot that we're using for our last off season. We basically decided to remake and just make an entirely new custom robot for this. So basically how we did this is we just made a drivetrain. We just did a cutout with a long piece of tubing across, and then we mounted it on. And so you might be wondering, this robot is actually illegal. And it's illegal because we wanted to basically just get it out as fast as possible and get something we could drive around. Because of just the design of the Kitbot, we needed it to be very wide and long because we wanted it to, we didn't want to change anything that FRC gave us, so we just accommodated for that. We also modified and added some extra things onto the Kitbot. A few of the things, well, the first thing that was talked about a bit before is the mini turret here, which we use. Originally was on a different drivetrain, but we moved it here for ease of testing, as well as being able to, for example, track the hub and move around and test it on an actual working robot. We also added a limelight over here, just sort of software to play with, as well as extra flywheels with, like, for example, inserts, just for some more rotational inertia to smooth out those shots. And so again, this is mainly for driver practice and really kind of testing any ideas and even moving things on. And it was a really great project. We got a bunch of rookies involved as well, and it's been great. We've taught a lot. We wired it all with rookies. It was great.
All right. So I'll talk a little bit about software. So since the start of the season, after we decided that we were going to build a turret for this year's game, we decided to build this miniature turret so that we could play around with it and get some practice in with implementing the control for it. So for starters, one of the encoders is detached, but basically we have 2 WCP through bores on relatively prime gears. So the number of teeth on the 2 gears is 17 and 18 respectively. And so because they are relatively prime, we're able to always calculate the position of our turret using the Chinese remainder theorem. And so that was something that we were able to implement and get working. Something else that we're going to be doing with the turret this year is that we will only seed the position using the absolute encoders at the start of the match. And that way we're not manually updating the position of the turret every frame, which would cause issues with our control loop for the turret. In terms of the actual handling of the turret, so we're going to have like dynamic states, because as the robot is translating and rotating around the field, the angle of the turret will change depending on the target that it is pointing at. And so that angle would be calculated every frame depending on the robot's position. And so there was a clip that was shown shortly about, or displaying how the turret was pointing at the hub. And yeah, that's where we're at with this. We're also currently implementing or testing the logic for handling the angle wrapping. Since our turret on the actual robot will not be infinitely rotating, it does have a limit. We believe it'll be roughly like 420 degrees in either direction. And so we need to implement logic that will make it so that if the turret goes to a position that would exceed the limit in either direction, it chooses to take the other path, which would be 360 degrees minus however many rotations it would try to do to get to that target angle. But yeah, that's that for the turret. As for the main robot, we decided on limelight positions recently. And on our main robot, because we have this like massive hopper that is going to be like blocking the turret, we can't really put a limelight on the turret. And so we decided we're going to put a limelight on the sides of our robot and have them angled so that when we are driving along our field walls, we're able to see the tag and be able to shoot from any of those positions. And that way we don't have to orient our robot away from the field wall, and we can be planted and have our wheels crossed, and that will make us stronger against defense. And yeah, that's about it for the limelight positions. As for auto strategy, we have been testing some autos on this Kitbot. There is like a clip of it running an auto and then getting beached, but the idea is that we want to go to the neutral zone and pick up as many balls as possible, come back, and then shoot everything. And because it's such a simple auto, there isn't a whole lot of pathing involved. And really, it's just how far are we going to be going into the neutral zone is going to be determined by the size of our hopper, how fast are we able to intake balls, and making sure that we're not colliding with our teammates. And so that's sort of the decisions that we have to make when we're developing our autos once we have the AlphaBot up and running.
I want to ask, one of the other teams that we talked to in Open Alliance mentioned them when they were doing their autos that it didn't seem like they saved any time by going over the bump if you had to slow down. Has your team done any testing in regards to like different pathing options, either underneath the trench or over the bump or anything like that?
Yeah, so we haven't gotten around to like testing autonomous and comparing over the bumper and under the trench, but we do think over the bumper will probably be faster because we'll be closer to the neutral zone, even if the robot will end up in like a strange orientation. We can still, control that and make it so that our intake is pointed towards the center, and that's probably a path that we will try to take. But I honestly, I can't tell. We have to do more testing.
Yeah, absolutely, and definitely a fair response to that as well too. I'm sorry, go ahead.
Yeah, sorry. So another thing that he quickly brushed up upon that I think is really cool is that we expect there to be a lot of defense this year. And so we were thinking of some ways to deal with that. And so Klein will mention things like Xing our wheels. So it's very hard to move us. But another thing is in 2024, we sometimes had some issues with our limelight going out. And because of that, we created, and other teams did this as well, where we press a button and it goes to a set shooter position right by the subwoofer in 2024. So you could just shoot, you could manually align into the subwoofer in case your vision or something wasn't working. We kind of have the same idea here. What we're going to have in our robot is we're going to have two buttons where basically if we're under a lot of defense or we want to or something goes wrong with our limelights, we don't really know where we are, we can just go cram ourselves into a corner, into one of the two corners, and we'll have two set positions where the robot will just shoot from there. So even if something goes wrong or again, we're getting pushed around, we have like a fail-safe for that. Is there anything that you want to?
No, I think that's pretty good.
All right, StuyPulse, thank you so much for taking time. Lots, I think, for teams to digest in this, but I really appreciate you guys showing, things that work, things that don't work, and I think that's a big thing about Open Alliance, right? It's just being open that, like, hey, not everything is going to go your way, and we're going to continue to improve based on that. So we really wish you the best of luck, and can't wait to see you in competition as well. Good luck the rest of the way.
Thank you so much.
Thank you.
Thank you.
Thanks for watching. Don't forget to like, subscribe, and click the bell to stay up to date on future fun videos. For over 100 years, Kettering University has offered a better education because from day one, that education has been built on hands-on, co-op learning. Kettering's impressive alumni network includes founders, presidents, CEOs, and frontrunners who have a reputation for transforming industries with their resolute leadership. Apply today at kettering.edu/first. AndyMark provides superior service and reliability that teams expect at andymark.com. From the Robotics Launcher Expansion Kit to the SDS MK4 and 5 Swerve modules, your team can be ready for rebuild. Don't forget to stock up on game-specific elements, bumper kits, and new for 2026 products at andymark.com.